Okay, good evening. Thank you. So the Infosys Prize for 2015 for Engineering and Computer Science is awarded to Professor Umesh Waghmare. Umesh, where are you? There he is, somewhere here. There he is. Thank you. Let me tell you what the citation is, and I'll tell you what the work really means. So the prize is awarded for his innovative use of first principles theories and modeling in insightful investigations of microscopic mechanisms responsible for specific properties of materials such as topological insulators, ferroelectrics, multiferroics, PZTs, and graphene. His work has a high potential impact in technological applications of these important industrial materials. So if you're like me, you're wondering, what is he really doing, right? Okay, so let me explain to you what I think this work really means and why is it so important. So have you ever wondered how your telephone works? So you speak into your telephone, there is a little material inside that takes the vibrations from your voice, converts that into electrical signals, it transmits on the other side, electrical signals get converted back into vibrations. So these materials are called special class of materials called PZTs, piezoelectric materials. And the P in these materials is for lead. And we all know that lead is a toxic, cancer-causing substance. And this is in every cell phone. It is used by the submarines. It is used by a whole range of applications where you need to convert electrical energy to mechanical and mechanical to electrical. Professor Waghmare's work is scientific in the sense that he uses atomic models of these materials, the electronic properties of these materials, and tries to understand through computer simulations how can I replace lead with something else, or how can I create a new material that has the same properties of these PZTs and equally effective. And this is a non-trivial problem. Even today, we don't understand how to synthesize materials by design. So this is one class of applications that he's concerned about. Another class of applications is materials that exist, for example, in nature, like niobium nitride. And these materials in bulk have one property, but if you create a very thin layer of this material, like 10 atoms deep, it has a totally different property. And this thin layer is called nanomaterials. And in these thin layers, he has shown that NBN, niobium nitride, can convert solar energy into electrical power. It can convert solar energy into hydrogen and oxygen. Another amazing applications if we are going to go into the hydrogen economy and to create electric power. This is really a great example of how science, which is the basic understanding of nature, can lead to great technological revolution and great engineering. So with that said, Professor Waghmare, we are proud of you. Congratulations.
Thank you. Before I invite Professor Waghmare on stage, here is a short video where he's talking about what motivates him to venture into the unexplored.
My primary motivation is just pursuit of science. There are limitless possibilities to explore. One has to be willing to take the path which is less traveled in research. There's a huge trend to work on a problem which is of great interest to a wide range of community and people, but it also is important to pick up a problem which is interesting to you, which looks adventurous, which may look unrealistic to begin with, but take the risk. I think it's worthwhile life to have.
Gentlemen, please join me in welcoming on stage Professor Umesh Waghmare. I request Mr. Srinath Bhatni, the anchor trustee, to join us on the stage as well. And may I request the Honorable President to present the Infosys Prize in Engineering and Computer Science to Professor Umesh Waghmare. Thank you. Professor, would you like to say a few words?
Good evening. I'm greatly honored to have received this important recognition, particularly from the Honorable President, Shri Pranab Mukherjee, in the presence of all of you here today. Thank you all. I express my gratitude to the Infosys Science Foundation for recognizing the kind of work I do in this particular discipline of awards. And it sends a very clear, timely message that the gap between science and engineering is diminishing in time, and I'm already seeing effects of this from several requests I received from young students to join my group in the last 2 months. This is a significant landmark in my career, and it's a big boost for me to continue with even greater rigor into this limitless domain of knowledge with more and more enthusiastic students. My small contribution to this field is a result of a lot of hard work, dedication, and even generation of ideas from my students and other members of the research group, and several collaborations I have had in India as well as abroad. I'm grateful to my institute, JNCSR, for providing me the ambience which is conducive to creative thinking. And my work never stops. And this is possible because of the unconditional support I receive from my wife, Varuna, and daughter, Kruti, and the encouragement from the rest of my family here. Thank you all.